for your lab. So hopefully you had a chance to look at it. We'll go into this equation a little bit more next time. It's called the specific heat equation, where Q is equal to delta H. Remember, delta H is the difference between our reactants and our products. Mass times specific heat times delta T. So we're going to be using that, but we're actually going to be using it where we set it equal to each other. So we had the metal and we had the water. So heat lost has to equal heat gained. As you did it, you should have been able to do all the calculations right here. Okay? So number 8 was just taking number 7 minus number 6. Number 9 was taking number 5 minus number 6, or 5 minus number 7. And then the specific heat of water was actually given to you on the front page right here, 4.184. So this table should be totally filled in. If it's not, quickly do that. So the only thing you're really going to need to turn in today is this, and make sure you did the quiz. We'll do today's work next time. Does that make sense? Whether it does or not. Your entire lab. We're going to go through the lab now. So now you're going to use this data to do the next page. So on the next page right here, I was so nice and kind and rearranged it, even told you which number row to take it off of over here. So if it says number 4, you take whatever it said number 4 was. And times it by number 10, whatever number 10 was. Times it by number 8, whatever number 8 was. But you do it for each sample. So I put a place right here so you could do the first one. So you're going to write CP. You're going to write CP. And then you're going to go over to number 4, whatever you had for your mass of water in the cup. That should be about the 100. So if I got 100.50 grams, that's what I put there. Times it by the CP of the water. That's number 10, and it's always 4.184 joules per gram degrees Celsius. Then I times it by number 8, which was the change in the water. I'm just going to put a bogus amount. You put whatever you got in number 8 for sample 1. Say that I got 13.76 degrees Celsius. You're going to divide that by big parentheses number 1, the mass of your sample. Should have been about 88 point something, 88.1, 80.0, whatever, grams. Times by number 9, which was a change in the temperature of the metal, and that should have probably been greater. So like I'm going to say 58.23 degrees Celsius. Remember when you go to put it in your calculator, though, on the bottom here, when you hit divide, you're going to want to put that whole thing in parentheses on the bottom. Okay? Not just each individual, because if you don't, it'll divide by 88, but then it'll times the whole thing by 50, whatever. You're going to do that for both of them. So you're going to set up the information here, and then you're going to put your answer right here. Okay, so on that table, so you're going to get your calculation, you're going to put your answer right here. Then right above here, I gave you the actual values you should have got. That's the literature value. So you have to know the identity of your sample. Maybe I had copper for number 1. And then I would put the literature value for copper, which is 0.385 joules per gram degree Kelvin. And then the last thing I do right here is find my percent error. And I've showed you how to do it. The literature minus the experimental divided by the literature times 100. You put that here. If you're really good, you should be less than 20%. Now, I know there's some metals that cool down so quickly it's going to be a higher percent. It's okay. All right? Just make sure, you've got a percent error here. Then on your last page, we've done this several times, error analysis, what went wrong? And what happens if my error is over 20%? Was there something that I could have accounted for in lab that caused that 20% error? We weren't fast enough moving it. Did I take some water, hot water with it? What could have possibly happened? And then we've got our conclusion. What could be the claim here? This is the hardest part for most kids, right? What could be the claim? What did we do this lab for? What were we trying to find out? Okay, that would be an easy one, but it's not really the whole purpose of the lab, is it? To figure out the specific heat of different metals in lab, right? Our claim would be. So whatever metal you had, trade that and say, to find out the specific heat of tin and lead? To find out the specific heat of copper and blue? What is your evidence? What did you do to figure it out? What observations in the lab helped you to be able to figure them out? And justification. Did your specific heats correspond to the literature values? And if they did, great. You know, you can say, justification, the evidence that I had made it able for me to figure out what the specific heats of the metals were, and they corresponded with known values. Or they didn't correspond with known values. I think there was an error. Whatever you need to do right here, okay? But claim is usually just one sentence. Evidence can be anything from lab. It needs to give me data, okay? Give me the numbers. Sort of like that detective movie, you know. The facts, ma'am, just the facts. So evidence is just the facts, what you got from lab. Justification is your reasoning for why these facts support your claim. Okay, and then turn it in, and you're done with this lab. Yes, ma'am.
So, how big is the number from the CP supposed to be?
So if you look at the literature values right here, the only one I don't have a specific heat right here for, that one group that did lead, you're going to have to Google it. Just say specific heat of lead. It comes right up. Just make sure you pick the one that's joules per gram degree Kelvin. Because there's one that's calories per gram degree Kelvin. If it says joules per gram degree Celsius, it's the same. Because Celsius and Kelvin are evenly divided, the same. Okay? Any other questions? Yes, ma'am.
So for my temperature, should I change them all to Kelvin?
No, you don't have to. Kelvin and Celsius are the same. Oh, some of you did brass. You're going to have to do the same thing if you did brass. Okay? If you did brass, I didn't have it on the literature values. Just Google search it. Yes?
So for the evidence, you want us to put the experimental value and the literature value as our, so what number do we?
You can. Mm-hmm. That would be good evidence.
I know.
Okay, are there any other questions with the lab? Okay, make sure you've got the quiz done. The lab comes up today. No notes come up today. Daily work 7.3 will do for next time. I think I called it daily work 7.4, but we're going to call it because it's on our fourth day. But 7.3 will be next time. Yes?
So what do you put in identity of metal sample?
So what kind of metal was it? What did you decide? So that's these. Okay? All right. Let me stop this, and I'll put this one up too.